Okay, we're going to look at two final properties of continuous random variables. We're going to look at the mode and the median and see how that corresponds to continuous random variables and how we can calculate them, how we can find them from some given examples. So first of all, the mode. You need to remember that the mode is the most common value or the most likely value. And so in this case, that's going to correspond to the maximum value of the probability density function. And we may have situations whereby the probability density function does something quite interesting for a while, and of course it's set to 0 afterwards and before. And in this case, the maximum value would correspond to the maximum stationary point. And so I can find that using calculus, either by hand to differentiate and set to 0, or of course if I've got my calculator will find that maximum point for me. But I also need to be aware of situations such as this, whereby the PDF may be defined as a function that doesn't necessarily have a stationary point. And so as an example like this, where the PDF is perhaps linear between two particular values and then 0 elsewhere, the mode here will correspond to this point here, which is the maximum value of the PDF in the given domain. But of course, I won't be able to find this using calculus because the PDF does not have a stationary point at that particular value. So knowing what these things look like is going to be crucial in identifying the mode. If we go on and look at an example, I've got a PDF here, 12x squared minus 12x cubed. And of course, I could sketch that if I chose to. If I've got my calculator handy, then of course that's going to be the quickest way to have a look at what this is. So I can see that that function looks something like this. So I can sketch it between 1 and 0. And of course, to find the mode here, I need to find that point. So of course, I can find f dash x, and then I can set that to 0. And then I can solve that to find x. And I'll leave you to complete that calculation and see what you get. And just to double check that you should have got as an answer for that 2/3. And of course, perhaps also worth double checking that you can get that directly from your calculator by finding the maximum point there. Of course, menu, 6 analyze graph, and use the maximum function there, number 3, will also give you that same answer of 2/3. Okay, we'll go on to look at the median, which, if you remember, is the value that splits the data in half, so that the median is such that you've always got 50% of the data above the median and then 50% of the data below the median. Again, we'll take a look at an example. We'll take the same probability density function as before, and we already know that it looks like this. So let's think about what property we're going to exploit. I know that the median is going to be the value such that half of the area is above and half of the area is below. So I can quite easily then set up the integral statement that says from 0 to m, the integral of f of x with respect to x will equal 1/2. And I can then set this equation up and try to solve it. I'll leave you to put the function in to integrate between the limits of m and 0 and see how far you get, and then we'll take a look at that in a moment. Okay, let's just go through and check we agree with what we've got. I put the function in, I then integrate it. I've still got the limits, I need to substitute the limits in, so I put the m in. I always, even if I know that the answer is going to be 0 for the second limit, I always put it in because every once in a while there's a function such as a cos function that when 0 is substituted in it doesn't equal 0. So I always make a conscious check there. And then I simplify to get this equation here, which if I solve this, I'll find the median. Now this equation here isn't particularly pretty. It's not a quadratic, it's not anything that I've got a quick method of solving. So at this point, if I was going to solve this by hand, I'd be scratching around trying to find factors. In this case, this is one that they would expect me to solve with a calculator. So we'll look quickly at the calculator methods that you can use. Probably the most obvious method, if you've already got to this point, let me just move this across a little bit. Let's get the calculator going, add a page, add a calculator page. I just need to solve a polynomial function. So if I go menu, I want to go to 3 algebra, polynomial tools. I'm going to find the roots of a polynomial, option number 1, and the degree of this is 4. So 4th degree polynomial, coefficients 3, negative 4, x squared coefficient is 0, x coefficient is 0, and the last coefficient is 1/2. Do that, and the calculator will tell me the answer is, I've got 2 answers here, 2 real answers, 0.614 and 1.247. Of course, remember that the domain of this particular function is 0 to 1. So clearly the answer here, GDCM, is going to be 0.614. So there's my value for the median. But there is a more efficient way. If I've got my calculator, in actual fact, I don't need to do any more than write down that first statement there. And the calculator will solve it from there for me. And I'll show you how. Let's go again. Let's put a new page on, new calculator page. I'm going to solve an equation. So let's go algebra, 1 numerical solve. I'm going to type in the equation. I can type in an integral equation in here. So again, menu, calculus, numerical integral. So option number 2 will give me this. I can punch in the lower limit of 0, the upper limit of m. The function is f2. I've drawn this as f2. I want to integrate with respect to x, and I've just got to make sure that the dx matches the variable in the function. I want that integral to equal 1/2, so I can set that equals 0.5. I then have to tell it what I'd like it to solve the equation, which variable the equation is in. So in this case, the variable of the equation is m. We saw before that the equation comes down to m. So I want to solve that, so comma m. So that's asking the calculator to solve this equation for m. And if I press that, it tells me the answer is 0.614 straight away. So I can actually save myself the time in even manipulating this if I've got my calculator. Clearly, if you're on paper 2, that direct method is the best one. If you're on paper 1, they'll set it up as a function such that you get an equation that is then easy to solve.